occupy their seat on this dais. Please, sir. To commence today's program with positivity and enlightenment, may I request our respected dignitaries to kindly come forward for the traditional lighting of the lamp to garland Ma Saraswati, the goddess of knowledge, and late Shri Bapuraji Deshmukh. Please, sir.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रधृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृति देवै सदा स्थिता मां पातु सरस्वती भगवती निःशेषजाड्या शुक्लां ब्रह्मविचारसारं वीणामुस्तकधारिणीं अभयदां जाड्यान्धकारां हस्ते स्फाटिकमालिकां पद्मासने संस्थिता वन्दे तां परमेश्वरीं भगवतीं धीप्रदां शारदाम्।
Light symbolizes knowledge, wisdom, and prosperity. May this lamp kindle the flame of learning in all of us. Now, moving towards the next segment of the program. Here, I request Dr. R.O. Pancharya sir to welcome our today's chief guest of today's program, Dr. Sri Hari Dodla sir, Assistant Professor, Department of Mechanical Engineering, IIT Bhubaneswar, Varanasi. Please, sir. Thank you, sir. Now, I would like to request Dr. U.D. Gullane sir to welcome our today's guest of honor, Dr. Nagendranath sir. Please, sir. Next, I would like to request Dr. G.D. Korde sir to welcome today's President of Function, Dr. R.O. Pancharya sir, Principal BDCE Sevagram. Please, sir. Thank you, sir. Now I take this opportunity to request Professor D.K. Bhingare sir to welcome Dr. U.D. Gullane sir, President of BDCE ISAM. Please, sir. May I request Professor Khobragade sir to welcome Professor M.M. Lohe sir, Assistant Professor, Civil Engineering Department and Coordinator of today's function. Please, sir. Now, I would like to invite our respected Dr. U.D. Gullane sir, President of BDCE ISAM, to deliver the welcome address for gathering. Please, sir.
Good morning, everyone. Respected Principal Sir, Pancheria Sir. Today's expert, Dr. Srihari Dodla, Professor from IIT BHU, Mechanical Engineering Department. Dr. Nagendra Nath, the scientist from DRDO, all the head of the departments, faculty members, dear students who are present here for attending this expert lecture, as well as the members who are attending this program online. This program is being uh, podcast on online also. So online attendees, all the ISAM dignitaries, on behalf of management and the family of BDC, I take this opportunity to welcome all of you for today's expert talk. The topic everybody knows. The talk is on the mechanical and tribological behaviors of fiber reinforced polymer composites, which is a very important topic nowadays as far as the development going on in the country, and the country is being a developed nation by 2047. The material requirement, material development is very prime, and both of these dignitaries which are with us, they are working in this area. So I welcome, and I think you should welcome them by a big round of applause. Welcome in our campus. Actually, ISAM is Indian Society for Applied Mechanics. BDC and ISAM has long history. We are associated with ISAM since 2017, when the team of ISAM along with late Dr. Karuna Karan and Dr. Lakshaman Rao and Vijay Bhaskar sir from DRDO visited our institution. Thanks to our Vice Chancellor, then Vice Chancellor, late Dr. S.R. Chaudhary sir, and our then Principal Dr. Girish Thakre sir, that taken keen interest to establish the ISAM chapter. And then fortunately Professor Doshi and many of the civil engineering faculty members got associated with ISAM. We got an opportunity to conduct one big program under the banner of ISAM, that is Swayam 2021. So that was a great success. After that, we were involved in small activities, but now we got this opportunity to arrange or to organize this expert talk. And now onward, I assure the ISAM senior members, advisors, and the president that BDC chapter will be active now and will actively involve in most of the activities conducted by the ISAM throughout the India. So I think this is sufficient for today's thing. So I thankful to organizers for giving me an opportunity to welcome the honorable guest in the BDC campus. I welcome you again, sir. Thank you.
Thank you, sir. May I request our respected principal, sir, Dr. R.O. Pancharya, sir, to address the gathering. Please, sir.
Thank you, Rutuja Madam. Dignitaries on the dais, Dr. Srihari Dodla, Assistant Professor, Department of Mechanical Engineering, IIT Varanasi, Dr. Nagendranath, Scientist, DRDO, Dr. Swatika, Modeling and Simulation Engineer, SLB, who is joined online with us, Dr. UD Gullane, President for BDC ISM, Professor MM Lohe, coordinator of today's event, all heads of department, esteemed faculty members and dear students. A very good morning to all of you. At the outset, I extend my warm and heartfelt welcome to the dignitaries on the dais. We are deeply honored by your gracious presence with us today. Your expertise in the field of fiber reinforced polymer composites is truly remarkable. And our students are fortunate to have the opportunity to listen you today's expert talk. It is indeed a privilege and a matter of great honor for me to welcome you all to this expert talk on mechanical and tribological behaviors of fiber reinforced polymer composites, organized in association with Indian Society for Applied Mechanics. Dear students, the Indian Society for Applied Mechanics was registered in the year 2016, and we are member to this association from 2017, as said by Dr. U.D. Gulane, sir. The society was conceived as a professional body of engineers, scientists, technologists to have common platform to come together for exchange of ideas, collective learnings, and knowledge dissemination through conferences, workshop, and lectures. In the series of these lectures, today we have organized this lecture for the students of engineering and the faculty members. This lecture on mechanical and tribological behavior of fiber reinforced polymer with composites is of immense academic and industrial relevance. With the growing importance of advanced materials and aerospace, automotive, marine, and defense applications, fiber reinforced composites are providing to be the backbone of modern engineering and engineering solutions. Understanding their mechanical strength, wear resistance, and performance under different conditions is crucial for innovation in design and manufacturing. Such sessions not only enhance the technical knowledge of our students, but also inspire them to pursue research and innovation in emerging fields of science and technology. Listening to faculty members like premier institutions like IIT, which is having the excellence in the field of engineering education, and the scientists from DRDO that represents excellence in research, will surely motivate our students to aim higher in their academic and research. On behalf of management, faculty, and students, I am very much thankful to the today's chief guest and guest of honor for giving their consent for this expert talk. I also appreciate the efforts taken by the organizing committee for arranging this enriching program. I encourage all the students to make the most of this rare opportunity provided by BD College of Engineering to listen attentively, interactive with our guest speakers, and gain insights to this particular topic, which will definitely shape your academic as well as future as well. With these words, I once again welcome all the dignitaries, participants who join in offline mode as well as in online mode. I welcome all of them, and thank you very much for giving me this opportunity to speak on this occasion. Thank you.
Thank you, sir. Now I request to our today's guest of honor, Dr. Nagendranath sir, scientist DRDO, to give introduction about ISAM. Please, sir.
Good morning, respected guests on the dais. So, very good morning to the head of the departments, faculty and students, and students whoever is participating in the online mode. I have been sent by my guide and Guru Lakshman Rao sir to represent ISAM as a easy member. And it's a good opportunity for me to see the facilities in a very rural area. And if it is beneficial for them, it helps a lot to the society. And I know that it is a local festival here. In spite of that, the management, the faculty members, students took great interest to participate in large numbers. So coming to the activities of ISAM, it all started with INCAM 2013, Indian National Conference on Applied Mechanics. It was trying to blend applications of mechanics in solid, fluid, and bio fields. Then our Lakshman Rao sir and eminent professors of whoever participated in that INCAM, they thought of having own society. There are many number of societies, but they are not addressing one particular goal. Like the mechanics remain same, whether you are applying it to solids or fluids or basically the mechanic remains same, but there are certain assumptions and all, and there is no uniform platform provided for them. So in that view, this ISAM society was started. My senior Dr. Vijay Bhaskar from DRDO, he is also an active member. Then the students of IIT Madras and other institutes have joined up, and this society has formed. And every alternate year, this INCAM series of conferences have started. Then these conferences were addressing only a state-of-the-art research. They are providing platform for state-of-the-art research. Then again, thought process came, why not involve students? Then the Swayam series have started, where the students only organize and students only participate. So that it is giving an opportunity for research students directly. Then there is a gap between state-of-the-art research and the fundamentals that are taught in the academics, undergraduate level. So the main idea is of this lecture series is to bridge the gap between the fundamentals taught in engineering colleges at undergraduate level or postgraduate level to the state-of-the-art research going on. So these lectures will, series of lectures, this is the second one. The first one was addressed by Dr. Lakshman Rao sir only, addressing by topic by impact mechanics, which will highlight and give a flavor of the topic and which will give an insight to the student to work in this area. Whoever has got acquainted with the basics or whoever needs a direction, he can get an insight on this topic. So this particular topic is for application of polymeric composites, which in this area, even we also work in aerospace as well as defense. And I request all students, whoever is present here and online, to learn the basics or bridge your understanding and gain your expertise here. Thank you, and I request.
Thank you, sir. Now, I would like to introduce Dr. Swatika ma'am. She is joined with us virtually. Dr. Swatika Minraj is a modeling and simulation engineer at SLB, where she is part of the whale construction equipment team based in Coimbatore, Tamil Nadu. She is also serving as Vice President in Indian Society of Applied Mechanics. So with this introduction, I would like to request Dr. Swatika ma'am to give the introduction of MLS concept. Please, ma'am.
Good morning to all. Whether I'm audible to the offline people who is in BDC, can anyone confirm?
Yes, ma'am.
Yeah, okay. Good morning to all respected dignitaries and faculties of BDC, our esteemed professors who have joined across our country, And a very good morning to the respected students who have joined both offline and online. So we have gathered here today for MLS Mechanical Lecture Series, a platform that brings together brilliant minds to share knowledge and inspire innovation. So let me give you a short history about this, how this MLS started. Like as undergraduates, like when we attend conference, even from my undergraduate dates, when we attend a conference, we'll be put into a blind scenario, like when a speaker comes and talks about all this mathematical equations, about like even on mechanics perspective also, we'll become blind. So we will not understand, as if we are put it in a very blind scenario when we go and attend a conference or workshops. So because these conferences and workshops are meant for scholars, PhD students and PG students and doctorates. So we thought, like, why not bridge this gap? And so we initiated a platform for undergraduates where we connect and foster knowledge on mechanics, because mechanics is nothing but it is on our day to day life activities. Even when we are riding a bicycle, like we be have enthusiastic in thinking in a way that why we doesn't fall when we ride a two wheeler, or even uh, uh, like when we are switching on stove, like how it works, like how electrical energy will be converted into thermal energy. So I mean, like even our day to day activities which has all this mechanics kind of questions and perspectives, so which has to be understandable in a basic level for the undergraduates. So we thought, why not there be a platform for the undergraduates to connect on this mechanics perspective. So our team, my teacher Professor Lakshmana Rao and Professor Chandra Prakash from IIT Kanpur, Professor Sudhamshu from NIT Jamshedpur, and Professor Shukla, director of NIT Jamshedpur, who is our present president of SAM, so brought up this MLS program. So this mechanical lecture series is kind of two lecture series we have per year. So we have a live audience in one of the campus where they will be teaching mechanics, and the transmission of this lecture will be made across the several registered sites across the country. So we will try to address the basic principles from physics, mathematics and chemistry. And since we have just initiated this, we were welcoming all your feedback, so that we can tailor further which has to be like satisfying what the undergraduates needs. So this MLS, this mechanical lecture series also includes a interesting contest, like the student design contest. So even today we'll be having a student design contest. So this is just to intricate the details of engineering problems in mechanics, which includes experimentation, analysis and also the design perspective. So we will have a short frame, structured frame of that. So the participants will be giving a presentation, and finally they will be evaluated, and the certificates and the awards will be distributed. So and the awards will be kind of a monetary basis, like a prize award will be given to the design contest winners. So already, as Dr. Nahendranath said, already MLS 1 has been completed in IIT Kanjipuram with 40 participants, and right now we are in MLS 2, and I see we have quite a lot of a large number of participants, probably like 250 participants from BDC and also from the online attendees. So we are very much happy to see a large audience here, and we are excited to see the design competitions. Like we would see more number of teams spread, like teams will be participated in the design competition and win the prize money. So let us maybe we'll start the lecture now. I think Professor Mayur can request. With this, I thank you, everybody.
Thank you, Swatika ma'am. Now, I would like to request Professor M.M. Lohe sir to introduce our today's chief guest, Dr. Sri Hari Dodla sir. Please, sir.
Good morning, one and all present over here. I am Mr. Mayur Lohe. Welcome you all here. I directly introduce Dr. Srihari sir. Dr. Srihari Dodla sir is an assistant professor in Department of Mechanical Engineering, IIT Banaras Hindu University, Varanasi. Sir has completed his BTech from the Venkateshwar University, Tirupati in 2009, and then he has completed his MTech in the solid mechanics from the IIT Madras. After that, Sir has completed his PhD in mechanical engineering from Otto University, Germany in 2015. Dr. Srihari Sir has previously worked as an research assistant and the broadcastal fellow at the UK and also Tel Aviv, Israel. He has received the DFG fellowship from the German Foundation and also DAAD fellowship from Counting the Doctoral Research. Also, he has the Israel government scholarship for pursuing the postdoctoral research at Tel University, Israel. His research focuses on the multi-scale material modeling, computational mechanics, polymer composites, and the crystal plasticity. Sir has published 30 plus research papers in the international journals. So thank you so much.
Thank you, sir. With this great introduction, now I would like to request our chief guest of today's function, Dr. Sri Hari Dodla sir, to interact with the gathering. Please, sir.
Good morning to all. Thanks for the introduction. I would like to thanks the organizers for making this event happens. So I am Srihari Dodla. So I work on this polymer composites and also composite material. My PhD topic on the developing a material model for the composite material having the two phases. So both experimental as well as numerical. So in this particular work, I am talking about the polymer composite mechanical and tribological behavior, enhancement of the properties, how we can increase the properties for the composites like matrix. It should be a polymer material, and for the coming to the fiber, it can be something like a particulates, something kind of a inclusions, or it may be a fibers in the form of unidirectional, bidirectional, or three directional one. So polymer composites, like for to fabricate, let's say like can you go to next slide? Otherwise you can give the keyboard. I will operate. So polymer composite, let's say like hand layup technique, we want to fabricate some composite material having the epoxy resin and hardener and the particles, something like nanoparticle CNT. So let's say like 0.25% CNT has to be there. We want to make some sheet 12 centimeter by 12 centimeters. So if that is the size of the composite material to fabricate, so we will take the epoxy with a like 120 grams and the hardener 12 grams. So total it will come 130 grams. And then for this 130 grams total volume, you can total weight, you can go for 0.25 weight percentage. If you multiply that total one, it is coming 0.33 grams. So you can take some A4 sheet and then you can measure the weight, set it to 0, and then you can take any container or something like a plastic cup. From there you can pour the epoxy 120 grams. Once it reaches 120 grams, you can keep aside. Similarly, you can take a hardener, and for the container you can set it to 0 weight, and then you can add 12 grams. You can keep aside. Now after knowing this, how much percentage of CNT, 0.25 percentage you want to add, that is coming 0.33 grams. You can measure in the weighing machine 0.33 grams, and you can add in the epoxy resin slowly. And then once you get a uniform mixture, 2 to 3 minutes, and then you can add the hardener. Once you add the hardener, stir it for a certain time, and then you can keep it on the something like a flat surface, and keep a something like a plastic sheet, and to make sure that not adhere on the plastic sheet, you can make silicone gel coating, and then you can pour your mixed resin in that one, and then go for the checking that is there any kind of bubble formation or void. So you can remove that either keeping in the furnace, and you can also remove it with the bubbles with the help of the some kind of sharp tools like pin kind of thing. So once it is cured after 24 hours, now you are ready with the composite material. So this composite material, you can cut it into as for the ASTM standards of the different testing experiments. Let's say like for the tensile test, you can cut a sample of length of 120 millimeters and the width of 12 millimeters and the thickness 4-5 millimeters. And then you can use that sample for the mechanical testing. Similarly, for the other tests, 3-point bend test and interlaminar shear strength and impact test, also there is a separate dimensions as for the standard. You can cut the sample and then you can straight away test it. So the idea here in this polymer composite materials, you can say like they are two or more chemically or physically separate materials. They can generate and produce a new material with having the whatever the properties we are looking, enhanced property. That means like fiber, if you measure separately, it is having a certain strength. Similarly, if you measure for the matrix, it is having a separate properties. But if you want to look for the optimized properties, high strength to weight ratio, and in that case, you can go for the mixing the fiber in the matrix with a different compositions by varying the volume fraction. So when you mix that different composition, you can see that there is an enhancement in the properties. So what is the limit? What is the optimal volume fraction, and what should be the fiber percentage can add? It will depends on the type of application and whether the property is increasing, or after reaching certain composition, whether the property is coming down based on agglomeration and other effects. So that it has to be checked. Let's say composite material, like when we are preparing some food item like poha or some other khichdi, some kind of items, you have a different ingredients in that. So you cannot call that as a composite material, right? Because microscopically it has to mix proper distribution. There should be compatibility, the fiber as well as the matrix. So that you can call it as a composite material. So in this particular figure, you have a unidirectional, let's say fiber, and you also have a matrix. We want to go for certain volume fraction, let's say 50% of fiber fraction. So we can keep the layer by layer, and we have to see that for adding one layer, what should be the fraction of the fiber. You can use burn-off method and you can evaporate epoxy, and then you are going to get the fiber. From that, you can measure what is the weight. So you can increase the layers, and then you can say that how many layers are required to get that particular thickness, 4 mm, 5 mm thickness. All right. So in that way, you can increase the volume fraction for the fiber case, whether it may be a woven type or it may be a unidirectional type. But in the case of particles, there you have to measure at the beginning itself before mixing in the epoxy. So, so that you can also change from the pure epoxy without having any kind of particles, and then you can add 0.25%, 0.51%, like that. You can increase the fraction of the particles, and then you can see that whether you are getting the desired properties you are looking, whether it may be a strength or it may be a stiffness, or whether there is a reduction in the quotient of friction or wear rate. So all those properties you can check, because the end of the day you are giving some kind of product. It should be useful, and also it should be a less cost, and it should be weightless. So composite materials, it is having advantage compared to metal. The first thing is weight. There is a weight reduction, and also they have a high strength to weight ratio. If you keep a constant volume, and you can compare with both the cases, metals and the composites, you will see that in that case, high strength to weight ratio for the composite case. So this composite material, they are having very good corrosion resistance compared to metals. You can make any kind of complex shapes. It's not like a regular shapes, like when you look in the fabrication process like casting. So there you have to give the mold, or even for powder metallurgy case, you have to design the mold in the regular shapes, cylindrical geometry, some kind of cubical geometry, some kind of flat geometry. But in the case of composites, you have a flexibility, like any complex shapes, any geometry you can construct. All right. So next slide, please. So if you classify the composites, you have the fiber reinforced composites, and you also have the particle reinforced composites. Particle reinforced composites, I mean, in the like when you add some kind of nanoparticles, carbon nanotubes, CNTs. Fiber reinforced composites, they are either short fibers or continuous fibers. You have a glass fiber, carbon fiber, aramid fibers. Glass fiber, it is cheap, and it is having a good strength, having the strength of 300 megapascals. And compared to the glass fiber, carbon fiber is better, high strength to weight ratio, and it is a bit expensive, but it is having the sufficient strength, like tensile strength around 600 megapascals. If you want to go for impact applications, aramid fibers are really good. So tensile strength, it will go something like from 1000 megapascals, but it is very difficult to cut aramid fibers. It's not easy with normal scissor cutting that. It is having a sufficient strength. That means whatever the force you applied is not sufficient with your hands. Okay, so different fibers will be there. So in the case of short fibers, you have an option, like you can arrange these fibers. You can make it as a small pieces, 5 mm, 4 mm, something like that. And then you can arrange in a particular direction, unidirectional. And you can also test you can also prepare the composite, and you can check the strength, and you can also distribute randomly in the epoxy resin. If you distribute randomly, also you can check that how the properties will change. So random distribution, it is something interesting, like people who are working on the metals also, because there, after the casting process, you have something like a grain structure, it will come, which are in random in nature. So you have the uniform properties if you measure the properties along X, Y, Z and other orientations. But in the case of preferred orientation, in that direction, you have anisotropy, it will be there, and the strength will be more compared to other directions. Suppose we have arranged the fibers unidirectional in the X direction, we can expect higher strength in the X direction compared to the Y and Z directions. Coming to the continuous fibers. So here, whether it may be a unidirectional or woven type is nothing but you have a fibers arrangement along X and Y directions. So also you have a possibility also three-dimensional case also. Unidirectional case, we have a single layer or multi-layer. You can go for not only with one fiber, either glass fiber or carbon fiber. You can also go for hybrid, one layer with glass fiber, and then you can pour epoxy and then make a proper bonding, and then once again you can change with the another material like aramid fiber or carbon fiber. So like that you can stack the layers with different materials, different fibers, or you can also orient the fibers 0 degrees, 45, 90 degrees, different orientation. So that effect also can be considered whether we are getting the enhanced properties or not. So bidirectional case, woven type 1. So you have ready-made available this fibers, jute fiber, pineapple, natural fibers, they are available, and also this glass, carbon aramid fibers, they are also available. Next slide, please. So you can see these different types of fibers. You have natural fibers. It may be from animal, or it may be from plants, or it may be from minerals. Coming to synthetic artificial, you can say like organics, carbon based, and inorganics, non-carbon. You have the different fibers you can choose depending on the type of application you are working. So based on the which application and whether the strength is the property or stiffness or something like reduction in the quotient of friction or something like specific wear rate you are looking, whether the wear has been reduced. So you have to choose the fibers accordingly based on the application point of. Next slide, please. So these are the different applications for the fiber reinforced polymer composites. When you talk about aerospace, so people are using for the wing screens and fuselage parts, and in all this interior structure and also these components. Coming to automobile, nowadays bumpers, engine components also they are replacing from metals alloys with the composite material. There is a like a 20% weight reduction you can observe in the vehicles when you change it to composite materials. Even for the marine applications also, you have this boat hulls, decks, masts, marine structures, and you can see that the weight has been reduced 25% lighter. Construction purpose also they are using for the regular constructions. You can see that they are replaced with the fiber composite materials. Sports and recreation facilities, it will enhance the strength to weight ratio. Wind energy applications for the 60-meter blade length, for the turbine case, electrical applications like insulation part, electrical insulation, consumer goods, they are durable and also they are lightweight in designs. Industrial equipments for the corrosion resistance or ease of handling those components. Sometimes it's very difficult to hold that heavy components to shift from one location to another location. So if the material is weightless, then it is easy to transfer from one location to another location. So coming to the infrastructure, so here pedestrian bridges, railway sleepers, they are also using, they're thinking that replacing these metals alloys with the polymer composite material. Next slide, please. So some of the components that which you can see on top of the frame: automobiles, windmill application, aerospace, fuselage, bicycle, prosthetic sockets, drone structure. People, they want for the lightweight and they're using for these composite materials. Next slide, please. So in this, some of the objectives, like in terms of enhancing the properties, how we can enhance the properties. So one possibility, by increasing the composition, we can enhance the properties. It may be strength or stiffness, or it may be a reduction in the quotient of friction. Other possibility is like modification of the surface, because when you are purchasing the fibers, it is already having certain coating for easily handling or movement from one location to another location. When you give some kind of treatment, chemical treatment with acid treatment or base treatment, you can see that oxidize it will happen, the properties it will enhance. So modification of the fibers by coating with CNT, carbon nanotubes. So it is in black color. You are going to get in the market single walled or multi-walled carbon nanotubes, and you can use the different composition to look at the application point of view. And if you want to look at micro level, like what happens when we are saying that properties in enhancing, is there any correlation with respect to the microstructure point of view? What kind of wear it is happening, and how the distribution of the fibers as well as the matrix at the lower length scale? That is also interesting. For that, scanning electron microscope, FTIR analysis, Fourier transform infrared spectrometry analysis. So in this FTIR analysis, you can see that whether is there any hydroxyl carboxyl groups has been formed. It says that the coating has been functionalized, it is functionalized, and you can expect that enhanced properties in this case. And thermal characterization, is there any stability issue for a long run? It's something like weight loss, it's taking place when you increase the temperature. For that also it can be compared with the uncoated as well as the coated fibers. So fabrication of different epoxy composites using hand layup technique, both unmodified, that means without coating, and modified with the functionalized one. So we are going to compare with how the properties will enhance. So once you fabricate the composite, after curing the composite, you are going to get a sufficient size, let's say like 12 centimeter by 12 centimeter or 15 centimeter by 15 centimeter, some kind of size. Based on that, you have to fix. So you have to know that for the different tests, what should be the maximum size bound, so that you can plan your weight of this epoxy as well as the hardener, and based on that you can choose the fibers with the different layers, and also nanoparticles fraction, how much percentage has to be added. So some of the tests, mechanical tests like tensile test nowadays, universal testing machine, it's in that one you can use, you can perform the mechanical test. You have an options like performing with crosshead movement, or you can perform with extensiometer for taking the strain readings. You can also use digital image correlation for capturing the region, and then go for finding out the reference and the final point to find out the displacements. You can also use transducer, LVDT type transducer, to find out the deformation. So coming to that 3-point bend test. So for the if you want to go for something like bending stress and flexural strength, you can go for the 3-point bend test. And also you have a tribological properties, reciprocating wear test. You can keep your sample and tighten it, and then you can perform this reciprocating motion with a hard ball, something like a chromium steel ball. And you can see that after giving sufficient load, and then the motor is running at a certain speed, 600 rpm, and then keeping at a watt temperature, that specimen it has to operate. And when it is going for reciprocating motion, so let's say like 10 to 15 minutes, you can see that the friction, coefficient of friction, it will increase, and then it will stabilize. And you can see that what happens at the micro level in front of like epoxy as well as the fiber or nanoparticles, how the wear it is taking place. Wear is a term like people are also using for this machining point of view also. Like when you are performing any kind of lathe operations, so there you have a cutting tool when you are working on very hard to machine materials like inconel or nickel based alloys. So whatever the tool, when you are operating, like when you are going to perform the machining operation, and after certain duration like 10 seconds or 30 seconds, you can see there is a tool wear. So that means the top layer and bottom layer, it is removed, it is eroded completely. So this is a kind of flank or crater where it is taking place. So it is very important, like you have to change the tool. So very hard to machine materials, it's very difficult to find it out which tool has to use without wear that, but without having any kind of failure or wear happens on the tool. So you have to choose the tools, some kind like coated tools, tungsten carbide tip tools, and then which are thermally, like it can be withstand higher temperatures also. So the wear is a crucial part. For some materials, it is not required to wear. For some materials, there is a wear is an option where it has to be considered. So for that, tribological properties like reciprocating wear test, we are using that machine for performing this, studying this friction and wear properties. Next slide, please. So we are working with different fibers. One is glass fiber, so it is less cost, it is having sufficient strength, and also carbon fibers, and it is having better strength compared to the glass fibers, and it is having very good strength to weight ratio. And to look for the impact applications, we shifted to this aramid fibers. And it is having more strength compared to the carbon fibers. So nanoparticles, we are using CNT, carbon nanotubes, multi-wall carbon nanotubes, nanoparticles. Depending on the particular application, we are looking for this enhancement of the properties for the nanoparticles case. For the coming to the matrix, we are using this epoxy LY556, LY556 and hardener HY951. If you change this particular grade, you have to change this ratio, mixing ratio 10:1, and you can based on the grade you have to fix this how much percentage of epoxy and how much percentage of hardener has to be chosen. Next slide, please. So for example, for one fiber case, we are explaining, like we are going to see that how we can enhance the properties. The first one is aramid fiber. As I said, we are going to get these fibers with different sizes in the market, and you have to choose a proper cutting operation to make sure that making as small pieces like 15 centimeter by 15 centimeter, depending on what is your size of composite you are going to fabricate. And you can choose depending on the how much composition you are looking, and how many layers, 3 to 5 layers, 6 layers, depending on the how much thickness you are looking, and also based on the volume fraction. So for this chemical treatment of the fiber as well as the CNTs, so for this particular case, we have used the acid treatment. If you are going for some kind of natural fibers, there is an option of base treatment as well. Sodium hydroxide, silane, and other base treatments also it is possible. For this particular case, it is an acid treatment. Nitric acid as well as sulfuric acid has been used in the ratio of 3:1. And so you can dispersion of these CNTs in acetone. So basically, we want to oxidize the surface, and you can make sure that forming the hydroxyl as well as the carboxyl groups on the particles or fibers. So once you go for dip coating of fibers in acetone, in CNT and acetone solution, then go to next slide, please. So you are going to get the coated aramid fiber, and you can also check that whether this functionalize has been formed or not by using the filter pH values, whether we are having that once it is neutralized after the coating. And once you have these coated fibers, and you can keep aside, and the same procedure like epoxy and hardener, you can choose based on the how much size you are fabricating. 120 grams epoxy and 12 grams hardener, it will make 10:1 ratio. And your fibers, you can choose let's say like 3-4 mm, you can go for 5-6 layers of the aramid fibers. Since you have already the coated one, it is already functionalized, so that you can also check with a small strip in the fiber, uncoated and coated one, and you can give it to FTIR analysis, and it will show that whether you have a hydroxyl groups and carboxyl groups has been formed on that. It says that it is functionalized. Now you can expect that proper bonding, and you have a sufficient proper strength or enhanced properties. So you can go for hand layer process, and you can go for adding the uniformly distributed load on the surface and cure it for 24 hours. And then once the composite is ready, then you can as for the ASTM standard, something like 150 millimeters length with 15 millimeters and thickness 4 to 5 millimeters, you can make a marking and you can cut, and at the edges you can make a smooth with grinding wheel tool. So once it is flat, then that specimen you can take it for the tensile test machine to perform this tensile test or 3-point bend test or interlaminar shear strength test. So next slide, please. So coming to whether we are saying that there is a property enhancement, we can increase the properties. One option, we can increase the composition, and there is a limit up to which percentage we can increase. After that, even if we increase, there is a possibility of agglomeration, the properties it will reduce. Other option is we can go for the modification of the fibers as well as the matrix. So for the aramid fiber, functionalization has been done with the help of the acid treatment, sulfuric acid as well as the nitric acid in the 3:1 ratio. We can perform FTIR analysis taking a small strip after coated aramid fiber. You can take a small strip, and before coating aramid fiber also you can take a strip, and you can perform this FTIR analysis. From that, you are going to see that transmittance as a function of wave number. And in this, the first image, you have a certain groups are there, and this is the uncoated one. The second one is chemically treated one. The only difference, there is a OH at 3445 wave number. It is formed for the chemically treated hydroxyl group. And also there is a, in case if hydroxyl group, if it is already there before coating, that value, it will be increased for the functionalized one. If it is not there, it will form. So in this particular case, there is no left side image, aramid fiber, there is no hydroxyl group, but in the second image, hydroxyl group has been formed. It says that it is functionalized and there is a proper bonding and it is oxidized, and you can expect the enhanced properties. Next slide, please. So similarly for the CNT particles, multi-wall carbon nanotubes, then you can choose small piece and then you can test in the FTA analysis. And you can look at once again here, there is a carboxyl group, C double bond O. So you can see in the chemically treated one. That same one, you cannot see it in the uncoated one. Okay, so it says that it is functionally treated. There is a proper bonding. You can expect enhanced property. Next slide, please. Coming to the SCM analysis, one thing is we are saying that coating has been taken place, functionalized, it has been taken place based on the FTIR analysis. Is there any any way we can visualize at micro level how these fibers or coated particles looks like? So when you make a small specimen like 1 centimeter by 1 centimeter, even 0.5 centimeter by 0.5 centimeter, cut and then make sure that cleaning the surface with acetone, and then you can take it in the microscope and make sure that it is electrons should flow, and if it is not flowing, you have to add some kind of silver solution so that electrons will flow from the silver solution. And once you have that, once you keep your specimen, make sure that electrons will flow, and you can select the region where you have this fibers as well as the particles. So you can see that for the before chemical treatment and after chemical treatment, you can expect that smooth flow on the fiber case, and in the second case there is some kind of surface roughness, it is taking place, some kind of a rough surface. Okay, next slide, please. So next one, functionalized CNT on the functionalized aramid fiber surface. So aramid fibers, you can see initially, you can look at like something like a green color contour, and when you look at micro level in the SCM, so you can see that you have a very smooth surface of each fiber one. And for the functionalized one, you can see there is a change in the color contour, and a lot of roughness you can see in the bottom image when we visualize in the scanning electron microscope. So it says that there is a kind of bonding and there is a kind of oxidation taking place, and you can expect that enhanced properties. Next slide, please. Coming to fabrication and to look at the how the arrangement, stacking arrangement, layer by layer arrangement, how the properties will increase. So for the matrix case, epoxy resin, and coming to lamina, so this woven type fibers, you can, they have the information along X and Y direction. Fibers are arranged along the horizontal as well as the vertical direction. We can keep in the same orientation layer by layer. Why we have to go for layer by layer? That means we need a sufficient size, volume fraction, thickness, and also if we increase the volume fraction, that means we are enhancing the properties. So that's the reason this laminate structure can be constructed keeping same orientation, or you can rotate the laminate. For the first layer 0 degrees, second layer you can rotate it by 90 degrees, third layer 135, fourth layer 180 degrees. So you can also orient and look at that stacking sequence. Is there any effect on the enhanced property? Next slide, please. So once you arrange this, and then you can go for fabricating the composite, and then go for curing. After curing, you can get this polymer composite. So TGA analysis, thermogravimetric analysis, for looking at the how the weight percentage as a function of temperature. So we can say that this CNT coating, it acts as a protective barrier. It will delay the or hindering the degradation of the aramid fiber by making some kind of thermal coating or some kind of thermal barrier. That means when you look at that, after 600 degrees centigrade, uncoated one, it is decaying, weight percentage is decaying faster, but coated one, it is taking sufficient time, some time it is having. Okay, so weight reduction, it is less in the case of coated one compared to the uncoated one. Next slide, please. So coming to the hardness values, as I'm saying that properties can be increased. Either you can use this Vickers hardness test or other hardness methods. You can choose a specimen 1 centimeter or 2 centimeter by 2 centimeter, and you can measure the hardness before coating and after coating, and you can see that after coating there is an enhancement in the hardness values compared to the uncoated specimen. Next slide, please. Coming to the tensile test, we have this Instron machine, and also we also having the machine with a different load capacity, 50 kilonewtons and 25 kilonewtons, 10 kilonewtons. So for tensile test, you can go for the preparing the specimen as per the ASTM standards, and since it is a composite material, for holding the specimen at the grips, you have to use some kind of friction reduced material or no friction one. So if there is a friction, there is some kind of frictional effects coming into picture. You have to multiply your load value with the coefficient of friction when you are taking the stress strain information. If you didn't consider the edge effects, if you want to avoid that friction, you can have some kind of Teflon or some kind of protective sheets, and make sure that there is no friction at the edges. So we are going to keep the specimen in between the fixtures, and we also have this extensiometer for measuring the deformation. And you can see that there is a failure after certain deformation. There is a failure on the uncoated aramid fiber with epoxy polymer composite, and the coated aramid fiber with the functionalized CNT and with the epoxy one. Next slide, please. So we can see that stress strain behavior, and we can expect that increased enhanced strength, and also modulus stiffness value, that is slope. So that you can compare with the before coating and after coating. So it's always advantageous going for the coating functionalized one. One option is you can increase the composition, and the second option is you can go for the arrangement, whether there is a proper bonding and how to increase that bonding between the fiber as well as the matrix. Next slide, please. So this is a for the tribological test, we are using reciprocating wear test. So in this particular case, we have for this particular setup, we have to take 2 centimeter by 2 centimeters and thickness 0.2 centimeters. And basically you have a motor having the rotatory motion. It will be converted into reciprocating motion. So you have a hard steel ball at this particular location, and that is made up of chromium, and the specimen you are keeping below that, and you are tightening with a screw. Once it is fully tight, and you can give what should be the load you want to work, whether it may be 20 newtons to 100 newtons, and temperature, at which temperature you want to operate, and how many cycles frequency you want to operate. So this information you can give using the control box, and then from the data software, and then you are going to get the information, quotient of friction, and also wear rate, or you can measure the specimen before performing the test, how much weight it is having after the test. So you can measure the weight. You are going to get the information of the weight difference. Next slide, please. So you can see that the friction coefficient initially increases for both the composites because of the plasticization of the matrix. And this is due to adhesion of the matrix, and some regions abrasion also it's possible, and delamination of the composites material surface. Specific wear rate, you can see that for the coated one, specific wear rate is reduced compared to the uncoated one. Next slide, please. And when we change the load, rather than keeping it 30 newtons, if you increase the load to 40, 50, and 60 newtons, you can see there is a linear increase of the quotient of friction because of the penetration of the, you can say that asperities penetration. And the quotient of friction, it is decreasing when you increase the number of cycles or frequency. So this is because the surface softening caused by the frictional heating. Next slide, please. So when we looked at after this tribological test, when you take that sample and then clean the surface and then keep it in the microscope, and you can see that how the matrix and fiber visualize. So there is a more breakage of the matrix as well as the fibers in the case of uncoated one. So if when you are applying the load, if it is not having the sufficient strength, with the less load itself, it will fail. That means there is no proper bonding between the matrix and fibers. For the second case, you have to apply more load because it is strong enough. It is having a proper bonding because of oxidization. And you can see that less breakage of the matrix and fibers. Next slide, please. So for the wear surface of the coated aramid fiber and functionalized CNT along with the epoxy for the 40 Newton load and 30 degrees centigrade temperature and 8 Hz frequency, you can see that delamination wear as well as the wear fiber fragments you can see on the surface of the, you can see on the microscope. So there is a kind of small fiber fragments it is observed, and also breakage and delamination is taking place at that particular length scale. Next slide, please. So when we are treating finally, like when we are treating with the aramid fibers and also CNTs, and you can see there is an enhancement in the strength, and also you can see that there is a reduction in the quotient of friction, and there is a reduction in the specific wear rate. And friction coefficient, it is increasing with increase in the load, but it is decreasing with the rise in the sliding frequency. Next slide, please. So next one is like when we are rather than using aramid fibers, if you use glass fiber reinforced composites with the multi-wall CNT, in this case, how the quotient of friction it is predicted. So in this case, the properties of E glass fiber, electrically conductive one, and there is also S glass fiber structured one, and epoxy resin composite, epoxy resin properties has been given, and properties of multi-wall CNT also has been given. For when you are going for the design competition, there you need the properties for running the simulation. So that anyway, I'm going to discuss after this talk during the design competition. Next slide, please. So when we are looking for the more number of layers, increasing the volume fraction, so we have to choose epoxy sufficient quantity for the 15 centimeter by 15 centimeter or 12 centimeter by 12 centimeter. You already know the weight of the epoxy and hardener, and from that you can say for 0.3 weight percentage how much weight it is going to come when you multiply with the total weight. Let's say like 0.25 percentage is 0.33 grams. You can keep that much quantity aside, and then you can mix with the epoxy first, and then once it is uniformly mixed, and you can add the hardener once it is cured, and you are going to get the CNT based polymer composite. And if you want to use it for the e-glass fiber, you can mix with the epoxy and hardener. You can pour it with the layer by layer on the glass fiber. And once you prepare this composite without having any kind of pores or voids kind of thing, then you can add the distributed load, uniformly distributed load, something like 30-50 kilos, and then you can cure it for a certain time. You are going to get the polymer composite. Next slide, please. So we have studied the same procedure for the similar to aramid fiber composite, same procedure we use for the glass fiber polymer composite as well. Next slide, please. So we have compared the pure glass fiber based polymer composite, glass fiber with multi-wall carbon nanotube mixed polymer composite, and we can see there is a increase in the tensile strength and also there is an increase in the stiffness, tensile modulus. Next slide, please. So we have also performed 3-point bend test. Whatever the dimensions, whatever the specimen dimension you have taken for the tensile test, same dimensions, it should be fine. 15 centimeter by 5 centimeter or 0.4 centimeters. So you can take those specimens for the 3-point bend test. You change the fixtures, top platen and the bottom compression platen or something like tensile fixtures, replace with the 3-point bend test fixtures and apply the load. You are going to get the information of the flexural strength for the both the composites and also flexural modulus, interlaminar shear strength as well. Next slide, please. So we have also studied for the impact. Is there any effect on the impact? We have the impact machine and we have the possibility of IJOD and Charpy impact test. So as for the ASTM standards, these are the dimensions for the two different test case, and you can perform the impact test, making sure that initially it is calibrated having zero value, and then once you release the hammer, you can see that the energy it will be raised. So that value it will be say that what is the impact energy. Next slide, please. You can see that for the IZOD case, impact energy, it is more for the multi-walled carbon nanotubes mixed with the GFRP polymer composite. Similarly, for the Charpy case also, you can see that coating, it is always increasing the property. It is in enhancing the property. Next slide, please. So for the, we have also performed this wear test and we observe that coefficient of friction as well as the wear rate. Next slide, please. So with increasing the frequency and also with increasing the load and temperature, we have studied this, how the coefficient of friction it is changing. Next slide, please. So we have also visualized micro level how the bonding between the matrix as well as the fiber and CNT case. In the case of without adding this multi-wall carbon nanotubes, you can see more matrix layer has been removed. Also, there is a matrix crack and more debris it is formed. But for the case of when you are adding this multi-wall CNT, this there is a good fiber matrix bonding is there, and very less matrix cracking you can take place. And also similarly for the worn surface under the same condition, taking the load of 60 newtons, frequency of 10 hertz and 30 degrees centigrade for both glass fiber reinforced plastic composite and also the GFRP mixed with multi-wall carbon nanotubes polymer composite. Next slide, please. So when we are doing some experiments, it has to be checked, or if it has to be in future, it should be some kind of design point of data we need. So for that, either you have the different options, like you can go for designing analytically, or you can go for numerically or something like machine learning AI based. So we have something like information of what are the fibers and what is the load, frequency, as well as the temperature. From that, we are finding out the coefficient of friction. So why can't we take those different test parameters of these input layers and then construct the function, from that function optimize this coefficient of friction value. Now the model, it will be there when you change this input parameters, when you change this fiber percentage, and also if you change the load, frequency and temperature, you can straight away say what should be the coefficient of friction value. No need to do any kind of experiments. Next slide, please. So in summary, you can see that there is an enhancement in the tensile strength as well as the modulus, and also flexural strength also and modulus can be increased for the mixed coated one multi-wall cylinder CNT particle-based polymer composite material. So also you can see there is a energy increase, impact energy increase, both from the ISOD as well as the Charpy test. So in the case of, you can see that for the coated one, less debris and also less fiber breakage you can observe, because you are getting the increased strength. That means there is some kind of bonding is there at the lower level. So very less breakage you can expect. So one tool, NN tool, has been developed for finding out, rather than doing the repeated experiments, you can simply choose the data from the user side and you can find out the friction value, quotient of friction value. So next slide, please. Okay, I would like to acknowledge some of the faculties as well as the scholars for helping in this work. So also financial support from the SCRB and also this DRDO for performing this work. Now I will go to the design competition, and after explaining that, I will take the questionnaire. Can you go to the next file? Can you close this and go to the next slide? Okay. So coming to the design statement, so you have seen that there is a possibility of property enhancement. Property enhancement, it is possible when you add the second material onto the first material. So how much increase can be expected when you add the second material? So this is interesting, because for the application point of view, everyone looks that that design should be better enough compared to the previous materials. If you want to replace something, it has to be better performance compared to the previous one. If you want to replace from metals alloys with the composite, you have to clearly say what are the advantages. Specific strength or something like increased like hardness or increased tensile strength, stiffness, better stiffness, like that. So when you are going for the addition of the second material, you have a possibility of adding the nanoparticles. They are, when you look at that micro level, can you remove that full screen mode so that I can show them? So when you add these nanoparticles, they are in spherical shape in the polymer matrix. So this nanoparticles, when we are purchasing, you are going to get the information of the what is the diameter or what is the radius. And I already said before, when you are going for enhancing the properties, you can add this second material, fiber or particle with a certain volume fraction, whether it may be a 0.258% or 1 or 2, based on how much size you are constructing. I want to construct 15 centimeter by 15 centimeter sheet. For that 15 centimeter by 15 centimeter, I know how much percentage of epoxy has to be added: 150 grams epoxy and 15 grams hardener. And for this, let's say like you can go for one weight percentage of CNT, you can multiply with the total weight. And from that, you are going to get how much percentage, how much weight CNT has to take. Maybe 0.33 or 0.5, whatever it may be, those many grams you have to take separately. And you can measure your container or plastic cup or whatever the supporting holder or cup, whatever you are using, you can measure that weight and you can set it to 0, and you can pour your epoxy based on the size of your plate. So 150 or 120 grams you want to make epoxy, you can pour epoxy, and then you can check whether you have exactly 120 grams. You can keep aside. Now you can take another plastic cup or the container and you can measure the weight, set it to 0, and then you can pour the hardener. And for that, it should be 10:1 based on your epoxy hardener grades. So 12 grams is sufficient. You can measure that 12 grams and then you can keep it separately. CNT, let's 0.25 weight percentage will come 0.33 grams. You can measure that and then keep it separately. And you can mix epoxy with that CNT 2 to 3 minutes and then add the hardener. And once it is added, and making sure that once you keep the surface is ready, making a silica or some kind of gel, making sure not for the plastic sheet there is no kind of adherence or there is no kind of sticking tendency. And you have a dies also, silicon mold dies, plastic dies, and also you have a cylindrical shaped dies also. Straight away you can purchase, and then you can pour that mixture epoxy with CNT as well as the hardener. And you can make sure that while pouring, it is like pores shouldn't be there. If you have the pores, whatever the desired properties you are looking, it is going to be decreased. So that means in that case, you have to take the percentage of the pore fraction also you have to consider when you are studying for the strength properties. So once you fabricate it, now you can cut the samples and then perform the tensile test, and you are going to get the stress strain behavior. Also, you are going to get from that you are going to get the stiffness and also the tensile strength value. And can you go down? So the idea is this design competition, especially undergraduate students, why we are looking like when you have some kind of design point of view, like when you are fabricating something and when you are simulating things, and you are going to go in the direction of in future going for startup or some kind of innovative projects. And so that there is a lot of fund in the institutes, IITs, NITs, their government, they are supporting coming with a new ideas. And whether what is your idea and whether you have that sufficient skills or not, and then based on that you can go for startup. And this it will give some kind of foundation for you how to fabricate and then how to perform the test, and how you can compare with the other mode, whether it may be analytical, numerical, or other machine learning AI based approaches. So you can see here, this is a one cubical geometry, and that blue color one is a epoxy with hardener, and you also have a CNT. Okay, CNT is, as I said, it is a spherical shape. Based on how much fraction you are going to get, you can construct that much size. You have a different options. There is a finite element simulation tool. All the packages they are giving student version, so free. You can straight away give your institute credentials, and then you can download that particular software. Abacus is one of the good software. You can download that, and the procedure is like this package. It is backend. It's a finite element programming. It is user friendly. You have to construct your geometry, and you have to assign the properties to that particular geometry. You have to say material model, and you can get the once you fix the boundary conditions, like how you are doing in the UTM machine, fixing at one end, and you are applying the load stress free at the boundaries, and you are going to get the stress strain behavior. From that you can find out the strength as well as the stiffness value. Whatever the values you are getting, it has to match with the experiment. So for that, either you can make some kind of empty regions, and you can go for constructing the spherical shape particles, and then you can assemble it both, or you can also make sure that take a control of the integration points, that is nothing but the material points, and you can construct the spherical geometry and surrounded with the remaining portion with the matrix region. So for this, if you take pure epoxy, that means there is no fiber, there is no spherical inclusions. Pure epoxy thing, you are going to get the complete blue color box. That when you perform the tensile test, you are going to get sufficient strength, stress strain behavior, and also the stiffness value. Now the second simulation, you can add 2%. Okay, so 2% you can volume fraction you can consider, and then you can see that whether the whatever the value you get for the pure epoxy case, whether that strength is increasing or not. Now you have added inclusion, so there is a kind of interface effects is there. The properties has to increase. When you increase from 2 to 5%, so when I mean like 2% spherical inclusion means remaining portion 98% it should be matrix should be there, epoxy one. So the next one is increasing furthermore 5% volume fraction of the spherical inclusions and remaining 95% with the matrix. So in this case, whether the strength is further increasing or not. So this kind of analysis you have to do in the first problem. Can you go down now? So other option, you have two cases. Either you can choose first case or second case. The second case, it is a kind of a woven type fiber. You have a fibers along horizontal as well as the vertical direction. You can see that yarn information. What is the fiber diameter? So when you after having these fibers like natural fibers or whatever the fibers, it is free. It is available with a less cost, and you can take a photo of that, and then you can take it any open source image tool, and then you can measure the you can convert from your units millimeter scale to pixels, and then you can measure that particular region. You are going to get the what is the fiber diameter, yarn width, gap width, yarn spacing, and fabric thickness. All this information you are going to get. Or for this particular pineapple fiber, I have also given the properties. So once you have the information of the fibers thing, now you can construct this kind of structure, kind of a wavy pattern. You can use any kind of design tools, CATIA, CAD, AutoCAD, SolidWorks, and then construct one construct one wavy pattern, and then go for mirroring option. You are going to get how many you want to get. Similarly in the other orientation. So other option, there are open source tools also there. You can also use that open source tools, TextGen and also other open source tools are there. You can use that, you can construct, and after constructing, then you can import that file into the Abacus, and you are going to show see the different parts like wavy pattern of the fibers and also matrix phase. Now you can assign the properties for the fibers as well as the matrix. Once you assign, now you can go for the applying the boundary conditions, loading conditions, and you can perform the tensile test. So in this case, for getting that fiber volume fraction 50%, you can increase the number of layers. You can measure what is the volume fraction from that open source tools or image also, you can find it out. So this is the second case study. Either you can choose the first one or second one, and you can compare pure epoxy and epoxy with the wavy shape woven type. You can say like bidirectional fiber, 50% or 52% fraction, whether you are getting enhanced strength or not. Can you please go down? So properties of the composite constituents has been given for this pineapple fiber. Like you can also choose any other fibers. For that properties, it is already available either in the technical sheet when you are purchasing, or it is already available in the literature. And CNT particles, for that also, matrix, epoxy, also you have the properties. And your task, can you go down? Your tasks are to perform the tensile test for the CNT based composites or pineapple or other fiber based polymer composites to find out the effective properties, elastic property. We are saying that pure fiber having certain strength, similarly matrix having certain strength. We are saying that for composite, we are looking for the enhanced property in between matrix and fiber. So for that one, we can say that effective elastic property, higher stiffness, whether we are getting higher stiffness and whether we are getting higher yield strength like that. And second task is like fabricating this composite, either with the woven type fiber with epoxy matrix, or you can go for the epoxy resin with hardener and CNT nanoparticles. You can choose any one, and you can compare effective elastic properties for both the cases. Either you can choose first or second one with increasing the volume fraction of fiber, whether we are seeing that enhancement in the properties or not. Okay, so can you go down? So some of the instructions how you have to submit your report. and literature review from where you got the information references, any paper or Google search, whatever the references you got, you have to make literature review and showing the results of the above contents, either analytical or experimental. Like analytical, it has been mentioned, experimental and numerical study you can compare. Analytically also you can do based on the rule of mixtures. I have a matrix, and if you add some kind of fibers, unidirectional fibers, something like that. So based on the rule of mixtures, you can say that effective property is nothing but the summation of the product of the volume fraction of the phase one times effective property of that particular phase summation. Okay, if you have matrix and fiber, you have to take the volume fraction of the fiber multiplied by the Young's modulus of the fiber, summation of the similarly volume fraction of the matrix, product of the Young's modulus of the matrix. So you can compare experimental as well as the simulation results, and whatever the conclusion, what you observed performing the experiments and also numerical simulations, whether they are comparable. If yes, what is the percentage of error, if there is anything, and what are the references you have taken, that also you have to mention. Go down, please. So some kind of suggestions, like you can choose any kind of resources. You will get a lot of open source now. You can find it out. You have to give a report with all the above information. So for the BTech students, we are targeting team size maximum should be 3. Only second year, third year students are allowed. So in the case of first year students also want to participate, they have to consider this 2 team members from the second or third year one. So there is a Google form link also will be there. It has to be certified by the certified by the faculty in that particular institute, and only in that particular institute the students, they have to join, make a group, and then perform the task. Can you go down? So these are the draft timelines. So this registration date, it is going to close on 27th August midnight. So for that, Google form link also has been given. So you have to submit reports with including the literature survey by 21st September on Sunday. So shortlist teams, it will be announced on the 4th October, and for the presentation of the shortlist teams on for the best design award on 11th October. So these are some kind of support we are going to provide. So I thank you all for listening, and if there are any questions, I am happy to take. Please. Any questions from the online participants or offline participants? Anything about this fabrication, enhancement, numerical part, and any other thing, especially for the design competition thing?
Excuse me, sir.
Yes, sir. Yes.
This is Prasanna from IIIT TDM Kanchipuram.
Yes, sir.
Can you go back to the slide where you had the SEM images of pre-treated and post-treated fiber, aramid fiber?
Can you go up? Down, down. Yeah. Can you? Yeah. Are you talking about this slide?
No, sir. Just a bit ahead.
Can you go up? Up. My images go up. About this one?
Yes,
sir?
that one. Can you go to the next slide down below, sir?
Next slide.
The enhanced zoom to, yes. So my question is, now when we talk about the fibers that are going to be used for making the composite, and we're adding carbon nanotubes, first question is, we're going to have the shape or the size of the particles, which is the nanotubes and the general fibers. they're going to be magnitude times different, right? We usually have fibers that are woven together, and that is considered as one fiber, right? Is this that, or is this an exact individual fiber that is in the size of micrometers?
Yeah, this is actually woven type fiber. So initial like how the fiber looks like that in the first image, and when we go for the functionalized one, that is the second image. So when we are looking at the micro level, so individual fiber, we can see that on the surface it's like a smooth one. But for the functionalized case, you can kind of roughness, you can see that. It is same for the other fibers also. You can measure. You can look at that scale, something like micrometers. If you go for the lower magnification, you can also see that this kind of roughness. It's a
Yes, sir.
kind of woven type fiber.
When we talk about, I'll just digress a bit. When we talk about vulcanization of rubber, there at the molecular level, you have sulfur bonding with interlayers of the polymers of rubber, right?
Yeah, yeah. So
Yeah, now the
chemical
question
bond.
is that same thing happening here where we have cross linkages forming, because, or is it like just the surface treatment is happening for individual fibers? I'm not able to understand the fact that just by increasing the surface roughness, is it because of van der Waals force, or is it because of increased friction between the surfaces of the fibers, we're getting better strength and toughness? Or can you explain that a bit more?
Yeah, actually, it's a chemical bonding is taking place between the cross-linking also happening. So the fiber to the matrix, if there is a proper kind of bonding, that means like we have to apply more load to break that bonding thing. So kind of, I would say like it's a surface one. We have visualized that how this functionalize as taking place, but we haven't looked at that initially cutting this further small sample in the transverse direction at the using TEM. There is a possibility, I think, looking at the atomic level. So in that direction, we haven't looked.
Cross linkages, if I'm right, inside the fibers.
Right, right.
Okay, yes, thank you.
Thank you, thank you.
Good morning. Can you hear me?
Yes, sir. We can hear you.
This is Lakshman Rao from IIT Madras. Thank you very much for a very nice presentation, and also a very challenging task here that you're given for the students. One or two points that I want you to also address is that can you say something about the cost of this carbon nanotubes? Is it something that is affordable even from somebody in a Sevagram, or only people in DRDO can afford it? Or second thing is about durability of the epoxies or all the polymers that we are dealing with, when they are environmentally friendly, or can you say something about the way the world is thinking about these polymers and their durability and so on?
Okay. So the coming to the cost point of view, for the CNT, we have imported from Germany. Nowadays, last 3-4 years, Rohan Scientific, there are some suppliers in the local region. So they are giving that CNT particles. You need something like 10 to 20 grams only, small quantity for performing this one. That is affordable. And I would say it's a open, rather than choosing CNT1, some other particles, nanoparticles also, ceramic base and alumina particles. You can choose any other particle. The motivation here is whether we are seeing that enhancement in the properties or not. And the second one is like why we are going for this polymer composite. Nowadays, if you look at here, all the industry, they want to reduce the size space. They are having already well established old alloys or metal based structures, and also this construction, those things. So they want to go for this weightless one. So it is some kind of a starting point. We are doing anyway at the like small scale, but that design idea, it will help to the industry or the production team think about to enlarge that application, like in industries like doors or some kind of construction items or all those things. It will be replaced with the polymer composites. So the huge advantage is there is no corrosion resistant and there is no like much maintenance things. So labor cost also, it will be reduced. So that is the advantage in this one, sir.
Thank you.
Thank you, sir.
Okay, we have a question from Chandrasekhar. When we apply transverse loading to the laminate, having a cutout, the exposed edges were getting teared off before taking full load. Is there a way to strengthen the exposed edges of the cutout, thicken something the edge of the cloth, and then use it for testing?
Hello.
Okay, so when we are fabricating also, when we are taking the sheets 12 centimeter by 12 centimeter, when we are making a small like sheets, so after fabricating, when we are distributing the uniformly distributed load, there is an edge effect. So we are going to cut that particular complete edge portion and making sure that there is no like a non-uniformly distributed. That means more epoxy with hardener without fiber thing. So edges will be cut and rounded. Cut, you can say that. Similarly for the simulation point of view also. So there the cross section in the transverse direction in the elliptical shape also has been chosen. So that edge effects, it should be neglected. That means it has to be removed. It has to be cut. Only the portion having the information of the complete fiber as well as the matrix with epoxy resin with hardener has to be considered. So this edge effects we are not considering in this. So it has to be removed. I hope I answered.
Yeah, okay. Thank you, sir.
Thank you.
Hello, this is Rajesh from Cochin University. I just want to add the same question that Lakshman Rao sir asked, in the sense that the composite being a polymer, how eco-friendly is this composite? Can you please detail about that?
So we have studied for this polymer composite. One is with adding the particles one, and also this fiber part one. See, basically when we are mixing something, we have to make sure that whether is there a interface effects has been considered or not, whether there is a proper compatibility, displacement is continuous or not from moving from one phase to the another phase, and whether it is properly boundary conditions, something like periodic boundary conditions or stochastic, that is also fine. Periodic boundary conditions, that means it is independent of what is your size, volume element. So if we take that effects, then definitely like we are close to the experimental observations. And once the model has been predicted, let's say like any mechanical test, and that model can be checked for the other kinds of test, bending test or something like nano indentation test, or yeah, so that in that way it can be validated whether the model is predicted as well as validated well before commercializing.
Sir, I think you didn't get my point. I was asking about the eco-friendly, I mean, whether it's recyclable in the sense that...
Okay, I got it, sir. I got it.
Yeah.
See, actually, we are using thermosetting polymers, thermosetting one, resin one. So thermoplastic is a recyclable one, but in this case, there is an issue with the like recycling thing. Unless until we convert polymers to monomers, then only we can recycle it. So that is one of the challenging things that we are looking at moving from the thermosetting to other kind of epoxy resins. Correct, sir. You are right. Yeah, we have this recyclable issue.
You are saying when we use carbon nano particles, we can't use thermoplastic method for manufacturing. Is it like that?
No, like this thermosetting, let's say like we have there is an issue with the recyclability, that is clear. And there are also people are doing work on this, converting this thermosetting for the recyclable kind of thing. In IIT BHU also, from ceramic department faculty, they are doing this. So I would say like the matrix, whatever the matrix we are choosing, that one, as you said, it should be something like recyclable, and also it should be useful for the application point of view. So for the thermoplastic, we haven't started at that work. Only for thermosetting we are working now.
Okay, thank you very much.
Thank you. Thank you.
Sir, this is Sudhamsu from NIT Jamshedpur.
Yes, sir. Yeah,
Am I
yeah.
audible,
Hi,
sir?
Dr. Sudhamsu. Yes, sir.
Hello, sir. Very nice presentation, sir. Sir, just for the this question is for the design contest. It also involves the first step involves fabrication, right? Before testing.
Correct.
In both the problems that you have mentioned. So, for the interest of students, can you just explain like how and where they can get this material? Because not everyone is really, we do not know where to get. So, at least the students.
Sure.
And where to get and how to do it. If you can share some video resource or point to some resource, then they will be able to proceed with that, sir.
Okay. So coming to the purchase part, I think this jute fibers, natural fibers, and glass fiber, carbon fiber, they are available in the Amazon and also local suppliers. And if you need any particular contact, I can share that who are supplying these fibers. And Amazon is you are going to get, and you have to purchase like in such a way that you have to fabricate. Especially for the woven type fibers, you need a 5 to 6 layers, right? So for that, how much quantity? So one big sheet is sufficient enough for performing your fabrication thing. So you have to make small pieces, something like 15 centimeter by 15 centimeter, 5-6 layers. And you have to, since I mentioned 50% volume fraction, so 4-5 layers, it is sufficient enough. You can get the volume fraction of that. You can measure that, and initially, and also while fabricating the epoxy matrix, epoxy resin with hardener, and also this fiber. So you can use burn off method, and you can keep that one small piece in the furnace and then heat it up, and around 400-450 degrees centigrade, and you are going to get this fiber, and you can measure that, and you can say that how much fraction for the fiber and how much fraction this epoxy with hardener. So coming to the fabrication part, and I will also look at that some kind of images, maybe it will be helpful for you. Can you go down this last page? Go down. Next page, next page, next page, next page, next page. Okay, so here also we have shown that fibers, glass fiber we have, and also treated fiber reinforced composite, untreated particle. Can you hide that portion? I can also show. So we have some kind of dyes for making the, that is also available in the Amazon. So or any like online platform. So you have a die something like 12 centimeter by 12 centimeters. You can straight away pour in that, so that after pouring and then making sure that voids will be removed and there is no voids, and then you can cure it for 24 hours. And once it is cured in, you can make sure that it is not adhering on the bottom surface. You have to use some kind of silica gel liquid so that it won't adhere the bottom surface. Otherwise, if you didn't consider that when you are after curing, when you are removing that, so you are going to waste that mold. You cannot use it for the repeated times. Similarly, for the performing this test, compression test, or for the tensile test, you can cut straight away from that particular plate, 15 centimeter by 15 centimeter over 5 centimeter, or like 150 millimeters length and 15 millimeters width, and thickness you can choose based on the number of layers of the fiber, based on the volume fraction of the particles. You can choose that thickness one. So once you have this sheet, and from there you can cut the specimen for the tensile test, and you can go for the performing the tensile test. I will also give that some kind of, can you go to next slide? Next slide. Okay, so this is how you can say that initially you have a fiber, glass fiber, and you can also do for other fibers case also procedure is same. You have to, for the natural fibers, there will be dust particles. So you have to clean it with the water, And then once you clean it, and then you can dry it for some time at the room temperature. And you can cut the sheets, fiber sheets, with the desired size. If you have a shortage of epoxy with hardener, you can reduce the size from the 120 grams to 80 grams, and from there you can choose the hardener 10:1 ratio, and you have to make sure that particular grade for the epoxy as well as the hardener, to make sure that 10:1 ratio. And you can cut it, and then you can keep it on the weighing machine, the empty plastic cup or some container, measure the weight and set it to 0. And then you can add the epoxy measuring 120 grams, and then you can keep it aside. And then similarly the hardener also measuring 12 grams, and keep aside. And CNT particles or fiber, you can, after cutting and making it dry and then keeping ready, and you can first make sure that plastic sheet, and on top of that some kind of non-sticky liquid you are going to pour, and then you are going to add this fibers as well as the epoxy resin layer by layer. 3 to 5 layers you can use, and for the natural fibers, three fibers to 4 fibers are sufficient. But for the like artificial fibers like glass, carbon, aramid fibers, you can go for 5 layers. And once you make a layer by layer, adding the epoxy resin and keeping on top of that some kind of flat surface, and then applying the load, uniformly distributed load, and then after curing you are going to get the composite which you are looking. So once you get that particular size composite, then you can go for the cutting the sample based on the ASTM standards. So those depending on which machine you have availability, and then what are the ASTM standards you are following. So standardized one people are using for 120 by 12 by 5. So you can also use other dimensions, 150, 15 and 4. Okay. So after performing the test, and from that you are going to get the information of the deformation behavior, and from there you are going to get the Young's modulus as well as the strength value. So in this way you can fabricate. Sir, did I answer your question?
Yes, sir. Yes, sir. Thank you very much.
Thank
Sir,
you.
both epoxy and hardener are also available on Amazon?
Yes, yes, it is available.
Okay, sir. Okay. Thank you.
Thank you, sir.
Sir, can polymer composites are used the electrical industry or as an electrical industry? And in support that, what sort of the phase you are getting?
See, we haven't looked in that direction, electrically conductive point of view. So we are looking only on this enhancement of the mechanical properties. So there are certain fibers you have to choose whether it is electrically conductive, and you have to make sure that some kind of functionalization, some kind of treatment going for the consideration of this electric effects. Something like if you look at this alloys point of view. So like there are materials, copper, silver, they are used in the pulse magnets. They can generate extremely magnetic fields. So they are using as a conducting wire for the pulsar magnets. They can generate extremely high magnetic field, and the maximum strength of the field, it depends on the what should be the strength of the conducting wire. So it will go for on and off mode. Whenever it is switched on, this conducting wire, it has to withstand for the high temperature and also electrical effects. It should be very highly electrically conductive. So that particular application, conducting wire, it has to be capable of taking higher strength and also electrical possibility. So for that particular alloy also, we have studied the enhancement of the properties by constructing this, by using this layer by layer stacking that people call as a eutectic material. So there, both the materials, copper and silver, they belong to 1B group in the periodic table. They are electrically conductive. They're electrically conductive, and at the same time they can get the enhancement in the strength, not only increasing the composition of the second material, but also sequence of arrangement of the both the phases. So in the same way, we have to look for the polymer composite case also, how we can go for treatment or choosing the fibers to get this electrically conductive applications.
What sort of the phase do you have carried out?
What sort of, could you please
phase.
Test, okay, for we have studied the mechanical and tribological test only. For the mechanical test, we have used the UTM machine for that finding out the effective property. For the tribological test, we have used the reciprocating wear test machine from Magnum. Electrical part, we haven't looked in that direction. So coming for the unidirectional case, in the market, you are going to get the bidirectional one. You can take a separately that, and then you can make a same width, or you can say like same length one, you can cut. And then when you are fabricating at that time, making sure that when you arrange in a certain fashion, let's say like horizontal direction. So when you arrange that unidirectional fibers and then go for the once again epoxy resin and then going for the same position unidirectional one, you are going to get the polymer composite. The advantage in the unidirectional, you can also compare with the effective property with the analytical formulation as well by using rule of mixtures. Okay, and coming to the bidirectional case, you have to depend on the numerical simulations. So that means in the bidirectional case, you have a morphology effects also, it will be there. And you have to take that particular shape morphology, and then you have to look at that, how we can construct that fiber morphology. And then you can go for fabricating that polymer composite with different layers, and you can perform the test in the different directions. So that's how we can proceed.
Can you get wearable weight out of this composite material?
Wherever. So wherever you are taking WEAR, where? Okay, so where thing we have a addition where, and that we have seen at that particular micro level thing, and delamination where also we have seen. So when you go for, I mean, we have looked for the static case only. We haven't seen that some kind of contacting body. One is reciprocating wear test. We have seen that keeping one body constant and another with the other body steel ball, we are reciprocating that. So here, I mean, if you want to measure that particular wear, there are, let's say like cutting tool, it is already wear on the flank face and the rake face. So you have a something like a profilometer, three-dimensional profilometer. You can measure that how much deep it is eroded. Similarly, on the transverse direction and also on the okay, you mean like it is not reactive kind of thing, human body. Okay, so we haven't studied in that direction whether that like that particular one composite can be also used for this, because the friction part is very low actually. When we are increasing the functionalization, quotient of friction is reducing. So we are also using some kind of chains and other things. So it should be like soft enough, and surface roughness will be very negligible. Should be better surface finish. And if you have a something like a roughness measurement devices, and by calibrating that, we can say that the surface roughness value along the Z direction or average surface roughness is very negligible in terms of micrometers. Then you can say that it is wearable for the human needs also.
Sir, we have two questions from online. Dr. Ashish Pandey has said, thank you for the insightful lecture. Can we make strong composites only from natural fibers and resins without using any synthetic materials? Do we have any examples?
Yeah, we are working now with a jute fiber. Pineapple fiber is also another option. See, basically, what property we want to enhance, that is should be clear. Natural fibers is a better option, I would say, like, because they are readily available without going for any kind of coating, and we can enhance the properties. So I would say like we are exploring with jute fibers, pineapple fibers, those things, and composite, looking for the both sustainable and also getting the desired properties. So we need a further analysis on this, not only these two fibers, but also other natural fibers or some kind of hybrid form, going for one layer with jute fiber, another layer with either with glass fibers, artificial one, or whether carbon fibers. We have studied with the glass fiber and carbon fiber. Similarly, when we go for the combination of this natural and artificial fibers, that is also another study for reducing the recycling wastage. And pure natural fibers, at the moment we are looking only on the jute fibers as well as the pineapple fibers.
Okay, hope it answered Ashish Pandey. And we have another question from Snehal. Is the technology is applicable to carry hydraulic forces without affecting its fluid original composition?
See, I mean, I understand that when you're talking about the during the curing time, we have to be very careful. Like curing part, we are performing the test, everything once it is solidified. So once it is solidified, there is no like a fluid part. It is coming into picture. It is a kind of you have a two phase. Or if you have a pores, it's a three kind of thing. So we have a phase 1 and phase 2. In this one, when we are able to capture that interface effects, that fluid part, it is not going to come into picture. So completely solid body we are studying.
Okay, thank you, sir.
Thank you. Thank you. Yes. See, sit down, please. So why I am stretching that when we are having the fabrication during that time, there is a chances of voids when you are mixing and how the stirring is taking place. So the void is means there is no empty space. So that means there is no sufficient material to hold that particular load. Voids, if you look at the material without having the voids and with voids, and you perform the test, the properties are different. You cannot match with them with the literature or references, whatever it may be, because void also playing a role. So to reduce that particular property, always that effect it will be there. So that's the reason when we are fabricating whatever primary processing, casting, or some kind of fabrication with hand lab technique. So people will clearly say that whether void effect bubbles has been completely eliminated or not. So that it is a challenging thing, making sure that completely pure composite, removing the voids. It has to be negligible. So then you can expect that close results with the numerical simulation.
I think we don't have further questions from online. Professor Mayur, if we don't have any further questions offline, we may conclude the lecture.
Thank you all. Thanks for listening.
Thank you, sir. Now, I would like to request Dr. R.O. Pancharia, sir, Professor Sheikh, sir, Professor Yuri Gulane, sir, Doshi, sir, to felicitate the today's chief guest, Dr. Sri Hari Dodla, sir, by Charka and Khadi Ruma. Please, sir. Now, I would like to request Dr. Pancharia, sir, Doshi, sir, Yudi Gulane, sir, to felicitate today's guest of honor, Dr. Nagendranath, sir, by Charkha and Khadi Rumal as a token of love. And D.K. Vingare, sir, please come forward, sir. Dr. S.V. Deshmukh, sir, please join. Thank you, sir. Every successful event is the outcome of teamwork. Thank you so much all participating and for joining online with us for MLS2. Now may I request to leave the meeting and program is concluded for online joiners, please. Every successful event is the outcome of teamwork, dedication, and support. To formally extend gratitude, I invite Professor M.M. Lohe sir for the vote of thanks. Please, sir.
Hello, Dr. Satika ma'am. I am audible to you.
Yes, sir.
Madam, you and Dr. Nagendranath sir will be discussed with the students of BDC now.
Yes, maybe I'll just give a quick information to the online people. So
Yes,
online participants, so thank you for joining the meeting with us. Hope you would have got quite insightful lecture what Professor Srihari have given us. Thank you everybody for joining us. You may leave the meeting. Thank you. Thank you all.
Those students who have joined online, please leave the meeting now. Only Dr. Swatika ma'am, Dr. Ashish sir, and Lakshman Rao sir, and team IIT Madras will be joined. All other, please leave the meeting. Thank you so much.